Hi everyone, my name is Rachel Bobbins and I'm an iOS engineer at Stitch Fix in San Francisco. I'm excited and honored to be speaking to all of you here today in Tokyo. A few months ago, I went on vacation and I decided to reread a book that I had first read. I decided to reread a book that I had first read 6 years ago, Don Norman's The Design of Everyday Things. This book was really influential in shaping how I think about applications and building delightful experiences for users. If you haven't read the book, allow me to give you a quick summary. It's all about combining ideas from design, psychology, and cognitive science to build a user's first focus when creating objects and experiences. The first version of the book, published in the 80s, was all about physical objects. They recently updated it, so it also talks a little bit about digital interface design. And the reason that I chose to reread this book while I was on vacation was because I really didn't want to think about coding for a week. I wanted to have a break. And unfortunately for me, as I was reading this book, I kept thinking about all of the connections that I could make between the concepts in this book and my work as an iOS developer. This book started to fail my not code criteria because I couldn't help but see the way that these design principles could also be applied to the design of code. And I kept thinking about it. I couldn't stop thinking about it. And I wondered if maybe I was headed off a dangerous cliff. Maybe my thoughts were totally off and I shouldn't be wondering this. Was I ignoring the obvious danger signs? I didn't think so. The more that I thought about it, the more it seemed like a great idea to combine these ideas and these two very, very different disciplines. I felt like I could learn as an iOS developer from the ideas in this book. And that's why I'm here today to talk to you about the design of everyday Swift. I believe that as iOS and as Swift developers, we want to do the right things for our users. We want them to be delighted when they interact with our app and when they interact with our code. As developers, as highly technical people, we want to write code that is readable, clean, easy to understand, easy to augment. And very often, we look to technical resources for new ideas about how to do this. And I think that by applying the ideas of design thinking, we can learn to think more creatively about how we write code and about how we structure code and about how we achieve our goals of writing clean and readable and testable code. So over the next 20 minutes or so, we'll go over a few things. We'll talk about who our users are. This book is known for popularizing the concept of user-focused design. And if we're going to focus on users, we need to make sure we all have the same definition about who our users are. After we've talked about who our users are, we'll talk about some of the ideas around user-focused design and how we might apply them to our work as Swift developers. Finally, I'll end this talk with a challenge. So if you leave early for lunch, you will miss the challenge. So who are our users? As developers, when we talk about users, we're used to thinking about the people who download our apps from the App Store and use them on their phone. If we develop enterprise apps, our users aren't necessarily the people who've downloaded them. They're the people who are required to use them. But at the end of the day, those users are the people who are interacting with the interfaces and experiences that we have built. For the purposes of this talk, though, those people are not our users. As Swift developers, our users are also the people who use the code that we have written. Our users are other developers currently on our team. They are our future selves. They are our future teammates. And we need to give those people as much thought and consideration as we give the people who download our apps from the App Store, because we want to make sure that other developers and other people who are dealing with this code base have a delightful experience. Furthermore, these people, these users, have an entirely different set of goals, needs, and concerns from the people who download our apps from the App Store. And we should give those goals, needs, and concerns consideration as well. So I want to give a quick psychology lesson based on some of the ideas in this book. It looks like a programming lesson, but don't let yourself be deceived. So I want to build a really, really simple iOS application. I want it to only have one view controller. The view controller has no interactions. It only has the word welcome in both English and Japanese. So to get started, we hone in on our goal. Our goal is to build this screen. Then we plan around this goal. We know that we want to have 2 lines of text. We want the English to be first, and we want the Japanese to be second. We want the text to be centered horizontally and vertically on the screen. We want to use auto layout so that as the screen rotates or as the app gets run on different devices, the words behave correctly. That's our rough plan. But now we can get really specific. We want to use auto layout to build this, and we want to use programmatic auto layout. And in fact, we want to use the NS layout anchors that were introduced in iOS 9 instead of the visual programming language. We also know that we want to use, for example, localization. So we have all of these goals in mind, and we've gotten really specific about them. We have a pretty good idea as iOS developers how we can go about building this screen. So we do. We perform the goal that we have set out for ourselves. We write the code. It's a really, really short view controller. It's about 20 lines total. We think we have it. We think that when we press this play button, we will see the app build and run as expected. And so we do that. And that doesn't look great. Something is off here. So digging in a little bit, we perceive that something is wrong. It's really obvious to us that we have not achieved the goal that we set out for ourselves. So we interpret the state of the world. We see the warnings. Okay. We see the warnings on the console, and we know that something is off. We can interpret these warnings. They can tell us something. They can tell us useful information. So we compare those warnings with what we know about iOS development and about how the application looks. We know that we have not achieved our original goal, so we set a new goal for ourselves. Our new goal is a little bit different from the old one. It's all about correcting the code that we have already written, not about building an app from scratch. So we have set this new goal. We go back into Xcode. I think I have an idea of how to fix this. I think that we just forgot this line here, translates auto resizing masks into constraints. It defaults to true. We set it to false. I think that when we rebuild the app now, it will work. And it does. Our problem is solved. We got what we expected. So this is rocket science right here. So now we can see that we've gone through what the design of everyday things identifies as the 7 stages of action. We actually went through these steps twice. The first time that we went through these 7 steps, I was really explicit and tried to call each of them out. The second time I went through these 7 steps was during the debugging process. And actually, we went through those steps really quickly and pretty much subconsciously. And the truth is that going through these 7 steps subconsciously is something that we as developers do thousands and thousands of times per day. It's subconscious, so we don't realize it. But as developers, as people who care about the developers who will continue to work on our code base in the future, we want to make it easy as possible for them to go through these 7 stages of action. We want to give them clues that will help them ease through these stages of action as they debug cryptic code, track down tricky bugs, and build new features. And so, in the design of everyday things, Norman identified 7 principles of design which correspond to these 7 stages of action. And over the next 15 minutes or so, we will go through these 7 principles of design and see how we can apply them to our work as Swift developers to write cleaner, easier to read code. One thing to note is that these principles are not mutually exclusive. There are relationships between them. For example, the feedback that you give to a user can affect the user's conceptual model of a system. Or the presence or lack of signifiers can affect the discoverability of properties of the code base. So we'll go through each of these principles in isolation, but I want to emphasize that as you write code, you should think about how these 7 principles interact with each other. And so in the design of everyday things, Norman draws all of his examples from physical objects, things like teapots or doors or light switches. I tried to draw some physical examples from the interfaces that we have on apps that we all have on our iOS devices, and then translate those ideas about interfaces to code and to programming. So I'm going to start off with an example of discoverability. On the display and brightness screen on the settings app of my iPhone, I intuitively know which actions are available. I look at this screen and I know that I can change properties related to brightness and how text is displayed on the screen. These actions are really discoverable to me. I don't think too much about how to do the tasks that I'm out to do. In the app that we just wrote, there was a little bit of an issue with discoverability. We didn't know that that flag had to be set to false until we ran the app. We wish we had known sooner. We wish we had discovered sooner that this was a required setting. So for users who are the current and future developers on our iOS applications, it's important to be able to figure out what features and properties exist in a system. Therefore, as Swift developers who are building code bases today, it's our responsibility to make sure that important properties of our code base are easily discoverable to these future developers. So, as we write Swift, there's a few ways that we can try to make sure that important aspects of our systems are discoverable. We can make liberal use of the public, private, and internal designations for methods and properties. That's a really obvious way to indicate to someone what should and should not be discoverable. Tests are another thing that can help increase discoverability because developers can read these tests to learn about interactions between objects and about the expectations that one object might have for another's behavior. Without tests, developers have to dig through your code to try to understand what properties might exist, including the ones that aren't immediately obvious. Another way we can increase discoverability is to use sensible method and variable names, especially ones that intuitively trigger autocomplete. One of my pet peeves as an iOS developer is that there are 30+ methods in the UI table view, data source, and delegate protocols. Of those 30+ methods, only 2 of them do not start with the phrase table view. Every time I need to add more than one section to a UI table view, I find myself frustratingly scrolling through autocomplete, wondering what the name of that method is. Number of sections in table view, I would argue, is not that discoverable. Finally, comments and documentation can be a great way to help developers discover properties of your code base that might not be immediately obvious. So for example, linking to a Stack Overflow to explain a workaround that you had to do, or adding a comment about a build process or a tricky dependency. These are properties of your code base and its system that wouldn't be obvious through code because they aren't coding related explicitly. But they are important to discover to developers who have to use your code base. The next property or principle that I want to talk about is feedback. When I open the language settings on my iPhone and I toggle it between English and Japanese, I get an alert asking me to confirm my choice. I don't actually speak any Japanese, so as a user, I really appreciate this alert because it prevents me from accidentally changing my iPhone to Japanese. This also has an added benefit, though. It's not just confirming my choice, it's also giving me positive feedback to let me know that the iPhone has received my tap and is responding to it. And feedback is all about providing information to users about whether their actions have succeeded or failed. Positive feedback tells a user that everything is okay. Negative feedback tells a user that something is not okay. I think that the worst kind of feedback is no feedback at all, because then a developer has to make their own assumptions and guesses and educated guesses about whether things went right or wrong. And humans are fallible, they might be wrong. So we should try to give developers as much feedback as possible while they interact with our code bases. And unfortunately, there aren't time machines yet. We can't travel to the future and let somebody know that they're doing it wrong. So as developers, we should try to give as much automated feedback as possible to the future developers of our code base. And I think that compiler errors and warnings are the most useful type of feedback that we can give somebody, because they are an immediate red flag in Xcode that something is incorrect. It lets the developer react and adjust their course accordingly. I think test failures are another useful type of feedback. When they all pass, they let the developer know that they haven't broken anything that we expected to be working. When the tests fail, it's a form of negative feedback that, hey, you've broken something and maybe you ought to go fix it. I think runtime crashes are not a very useful type of feedback because as a developer, we have to remember what conditions and what steps we went through in order to trigger that crash in the first place. Furthermore, runtime crashes will only get triggered if we go through the right steps to trigger them. So as developers, we should try to make as much of this feedback as automated as possible. There's also types of human feedback that we can give, for example, through pair programming or code reviews or bug reports or app store reviews. The problem with all of this feedback, though, with the exception of pair programming, is that it's asynchronous. We don't get that information immediately. Pair programming is pretty awesome in terms of getting feedback, but again, we don't have time machines, so we can't go pair with the future users of our code base. The next principle that I wanted to talk about is the conceptual model. My favorite illustration of conceptual models is when Steve Jobs introduced the iPhone in 2007, and at the time, smartphones were not very popular. If he'd gone on stage and told everyone, hey guys, here's a new smartphone, people would have been like, what's that? Is that like a fancy Motorola Razr? I don't understand. So Steve introduced the iPhone in terms of something that people already knew. He told everyone that he was introducing 3 new devices that day: a widescreen iPod, a cellular phone, and, in his words, an internet communicator device. And he repeated those 3 phrases over and over again, and finally asking people, do you get it yet? It's all one device. And I think this was a really great illustration of conceptual models because he explained a new concept in terms of something that people already understood. And I think that as developers, we too often think about the code purely logically. Well, this function works, it returns the right thing. But we don't think about the fact that other developers, the ones who are using this code base in the future, are going to form their own conceptual models about how our system works. And people's conceptual models are influenced by things inside of our control, things like feedback and signifiers and discoverability. But they're also influenced by things outside of our control. Somebody's background, their travels, their cultural experiences, whether they're an optimist or a pessimist. All of these things affect how people develop their own conceptual models. And as developers, we can use the other 6 principles of user-focused design to give them clues about what a correct conceptual model might be. In the previous example that we went through, the quick little view controller, my conceptual model was that as soon as I created one auto layout constraint, auto layout would just work. That conceptual model was wrong. All right, the next design principle that I want to talk about are affordances. Affordances are relationships between users and objects, which allow people to take actions with those objects. So on the display and brightness screen of my iPhone, I am afforded the ability to take action to make the screen more readable. Affordances are something that were really emphasized in the 1980 version of Don Norman's book, and he actually emphasized them a little bit less in the 2013 revised edition because digital interfaces, like apps that we use, tend to have fewer affordances than physical objects. So that's just something to consider as we talk about this principle. But I do still think that it is applicable because For our purposes as developers, we can think of the fact that methods afford calling, variables afford getting and setting, but declaring a variable with a var as opposed to a let also affords resetting it. And as developers, we can think about what abilities and what actions our code is affording the future developers of this code base. If we don't want them to reset a variable, for example, we shouldn't give them an affordance to do that. We should declare it with a let. The next principle that I want to talk about, which is one that Norman had emphasized a lot more in the revised edition of the book, is signifiers. Signifiers are one of my favorite principles, and they are all about perceptible signals about what can be done. So on this brightness slider over here, I see at least 3 signifiers. I see 2 icons which signify the relative minimum and maximum values at each end of the slider. I see the fact that this is a slider as opposed to a set of buttons, and to me that signifies that this is a continuous spectrum, not a set of discrete values. Finally, I see the current position of the slider, which to me signifies the relative value of brightness as it currently is set. And one of the things that I love about Swift is that it is chock full of signifiers which we can use to send messages to the future users of our code base. So public, private, and internal are an obvious signifier about where a method is intended to be used. But there's others that are maybe a little bit less obvious. So for example, data structures. We have enums, we have structs, we have classes. I see enums as a way of signifying that we have some known set of values that are somewhat roughly equivalent to each other. I see a struct as saying, hey, this is something you can pass around by value and copy it all over the place and it's totally fine. When I see a class, I see a signal that this is something that is passed by reference, and I assume that the fact that it is passed by reference is important. If it's not important, then maybe a class is the wrong data structure to be using. And so I think that some of these signifiers are open to interpretation about what they might signify, but it is something to consider as you are making your design choices as a developer, is that every single choice you make and every line of code that you write is some sort of signal to the future developers. And we should try as hard as we can to make sure that we're sending them the right signals. Another design principle that I want to talk about is mappings. Mappings are all about spatial and temporal relationships between controls and actions. On the screen here, we have a screenshot from my company's iOS app. It has a button to continue checkout, and the button has an arrow that points to the right. This takes advantage of, in the Westerners' mappings, of the fact that time moves forward, and the next thing is always to the right. And so mappings are something that are culturally dependent, and again, just think carefully as you lay things out spatially what those mappings might signify. And so the one example I could think of for this as it relates to iOS development is how your Xcode project file is organized. And the way that you group your files and the way that they relate to each other signifies something to the user. And we want to make sure, as much as we can, that these mappings make sense. The last design principle that I want to talk about is constraints. Constraints are all about guiding and restricting actions. In the real world, for example, scissors have natural constraints in the forms of where your hand can be positioned on the scissor. We're guided towards putting our thumb on over there and the rest of the hand on the other part of the scissor. And there's really only one way to use a scissor like that. And I think the best example of constraints in Swift, and it's a really strong example, which is why there's only one, is Swift's type system. It provides a fantastic set of constraints because if you try to do anything that goes against the type system, you'll get a compiler warning that negative feedback immediately. The type system provides information about how methods can be called and with what types of arguments. And Swift's type system prevents a whole class of mistakes that were previously possible with Objective-C and now are not possible with Swift. So to recap, over the past 24 minutes, we've had a quick book report, a quick psychology lesson, a quick Swift app, and we've dabbled in some design theory. I hope that as you leave this talk, I'll have piqued your interest in the ideas of user-oriented design. As developers, we earnestly, sincerely want to write clean, readable, and maintainable code. And too often, we only look to other developers and the software engineering discipline about how we can accomplish that. I think that design thinking can give us a fresh perspective and help us to think more creatively about how we write code. But maybe you are not that interested in design theory, or maybe you have another field or passion that you are really interested in. Whatever it is, I'm sure that there are philosophies and principles and ideas that you can apply from your other interests to software engineering. I think that by cross-pollinating your development practice with ideas from other fields, you'll be able to be a more creative and more effective developer. Thank you so much for listening to my talk today, and enjoy your lunch.